we just got back our part from the machine slash welding slash custom fabricator shop. It was quite a hassle to even find somebody to be willing to do this. I went to about 4 places prior, and then it was only on the 5th place I found somebody that was actually able to do it. It took me most of a day just to find somebody to do it. So imagine how much time that cost me. But at least we got it done. So this is what we have here. So it looks like, I think it came out pretty good. So we ended up cutting off those protrusions, those 3 protrusions, as that made the most sense, because what we ended up doing is we bored out this piece here a little bit, and so this piece is actually receding into that now. So that's the only way we could get it really good in the center without any other method. I think that was the best way we came up with there. But we did lose a little bit of our keyed area. That's the only thing I'm a little bit disappointed about. We lost a little bit of our keyed area. Our mounting spot right here has been reduced slightly, that's the only negative thing about this. But we have some extra benefits though. This overall width has been reduced, so that's good. So we should be able to, it gives us a little bit more, since we're dealing with such tight tolerances here, it gives us a little bit more room to work with here. But we're still going to have to cut this shaft off if we really want it to work here. Or we're going to have to build some sort of wider adapter plate, which I'm still debating about which way we want to go with that. But I would like to, well, I would like to keep it as simple as possible and then just not have to do a wider adapter plate. But we'll have to just see how this all goes here. So that's how that's resting on there. So that looks pretty good. What I've just recently purchased here, I think it's going to help us in our quest here to get this thing to work. So I just found this at Harbor Freight. It's a cutoff wheel. So I have 2 angle grinders, but they of course have a blade go in this direction. It spins that way. It spins parallel with the thing here. But this actually goes to right angle to your handle. So what that allows us to do is, I believe it's going to allow us to get in here and cut this guy back, which is great because there's no other way to do it. You can't get in there with a saw. This might be the only tool we have that might give us a shot. And because we can get in here that far, I think we can take out that sleeve as well. Here's what it looks like. Completely processed and done. That is some nasty, nasty work. I'm not going to lie. This is, you definitely want to have your respirator on, lots of heavy gloves, and be prepared for a lot of dust, smoke, and sparks flying everywhere. The aluminum doesn't do it as much. The aluminum's actually no sparks at all. It actually just a lot of dust, but no sparks. But when you get into the hardened steel stuff, this stuff, man, sparks like crazy. It took about 15 minutes just to cut through that too with that grinding wheel. It's ridiculous. But anyway, we got the job done, so that's all that matters. So now we put on our coupling right here, our custom coupling. Set it in about as far as we can get it, so there's no interference here. Pretty much butt right up against it. That's about as far in as it can go. And then you just take your level, put it on your transmission bell housing here, and that's just to determine our face of plate right there. And then you just take a measurement from the outer edge of that to there, which I just did. That's 22 millimeters. And then that's how much clearance we have. And then what you do is you put this over here on your motor. Make sure it's in all the way. And then you take your plate. So we're going to be using right here. And then you take your measurement from the plate, face of plate, to that same coupling. And in this case, it's about 30 millimeters. So we're going to have to take off about 8 millimeters here. We have 8 millimeters of conflict here, so we're going to have to take off another 8 and or shim. We could put some shims between the plate and the bell housing to push this motor out a little bit as well. But I think that would be the last resort. I don't really want to do that. That's messing around with stuff here. So what we're going to need to do next is to go ahead and measure about 8, but we could probably just make it 10 to just to be sure, because in case the cut's not perfect or whatever, we want to have a couple millimeters of extra. It's not going to take too much material off here. 10 millimeters is about 3/8 of an inch or so. Here's what the shaft on the motor is looking like after we chopped off that little piece right there. It works pretty good. It took a long time to cut through that, and that was a sharp blade too, so it's not, once again, we're dealing with some really hard steel. And now we're cleaning up our motor shaft a little bit more here. Just making sure that this is about as square as we can get it here. Grinding off the edges, make sure it's nice and smooth. Then I went ahead and cut our key material because it wasn't exactly the right size, so I got it down pretty close. Nice and flush now. We can basically stick our coupling on, just like so. Just kind of go on without any effort. Probably just hammer that in a little bit more just to get it lined up. And that's pretty much all we have to do. I mean, we'll just have to tighten this down once we're ready to install, and then that will be it for that. Now over here, I've been preparing our bolts. So we're going to have 4 of them. These are 3/8 bolts, so you're going to have to buy these separately. This being an American motor, it has the SAE standards, so it's not metric. So you get 4 of those with locking washers. These are 1-inch bolts right here. That's what we're going to be using to attach our motor to our adapter plate. So that brings us to the adapter plate here. So that's what we have right here. I've been just playing around with it a little bit, trying to figure out how we want to put our motor orientation, because we have the option of pretty much doing anything we want. We could rotate this motor around this axis here anywhere we want. So if we want these connectors up top, or if we want them out front, or if we want them at a 45, or anywhere in between, we can do anything we want. So I was looking at it further. We have enough room to just leave it on top here as it's kind of resting right now. Here's what it's looking like with the template all cut out and installed now. Just have it loosely installed here. We'll tighten this down, basically simulating how it would be if it was actually the actual plate. And then all we have to do, I've gone ahead and tightened this up. Actually, this is now in. There's no reason to take that out again. That's been tightened down. So now, we could basically just go ahead and roll this in. We've got the motor in location. We've got it jacked up here. So it's looking pretty good here. So we have all of our heights just about right now. So the most important thing is, now that we have it lined up, if we want to make sure that that coupling gently goes into the spline shaft there. Don't want to force it, don't want to like come at an angle. We want to make sure that it's lined up and it goes in nice and gentle. And then everything else we can adjust. Here's our motor installed temporarily using the cardboard template. So we've got it fully installed here, just verifying some of the bolt locations. So all of them lined up, well, 3 out of 4 lined up fine. And then one of them was a little bit off. But that's why we're doing the template, and that's why we're doing the loose fitting here, is we want to make sure that these bolt holes are correct before we do our final cutting. So we just had to make one adjustment, and that's all. So that's pretty good here. One thing I found that was really helpful right here, I don't know if you can see this, it shows up on the camera, but I drilled a hole out right here, as you can see there. And what that does is it allows us to see in the spline shaft, how the motor is connected. I don't know if that shows up or not there, but I'll try to get in a little bit closer. But it shows how our motor connects to our coupling, the shaft, you know, the spline shaft. So, because I was having a lot of difficulty doing it blindly if I didn't have, but when I cut out that hole, I was able to get a better sense of what was happening, and to get it lined up perfectly. Because otherwise, there's really no reference point. There's just nothing. I mean, you can kind of look at it through the crack here, but it doesn't really. It's very limited, and then once it gets closer in, that crack goes away, so you don't even see anything. So it's really, or you just can't get any light in there. So I just found that it was just a whole lot simpler to just drill a hole through here, and it makes life a whole lot easier. And as far as, there's no no issue with structural integrity here. I mean, it's just one little circular hole. I mean, it's not anywhere near any place that's holding the structure together, so it shouldn't be a problem. This is only aluminum too, so it cuts pretty easily. So anyway, that's what we had to do here. It really makes life a whole lot easier. So other than that, we didn't have to change anything. It went in relatively easily. I mean, well, it was a little tricky. I mean, you gotta, because another thing that you have to take into consideration is that this angle of this thing has to be perfectly straight with the transmission. So, you know, this has to be perfectly aligned. Otherwise, you get a little bit of resistance. So I did have to kind of wiggle it around in there. It's actually about halfway on there, maybe 3/4 of the way on there. I don't need to put it all the way on. I just needed to get it, you know, fully on the spline, lined up correctly, and then so we can get our template basically finalized. We have enough room here that we can actually maneuver this around here with no problem. So we won't have to take the motor out any further than what we're at right now, since we can just roll this around here. Well, obviously I can twirl this around here and get it to the point where I can have real easy access to our template here. So we're going to remove our template and go ahead and cut out our plate. And when we reinstall our plate, it will be just as easy as what it is right here. It's not going to be any bigger. It's going to be the same size. So we'll be able to simply put our plate back in and then simply just roll this back into position. We've already have the height fixed, so we're good to just simply slide it back in. So it's going to make it real easy to put it in and out. So now we have our plate steel laid out here, and we've got our template. So we'll go ahead and just simply place our template on top of our plate, pretty much like so, and go ahead and start marking it up, and then we'll start cutting it out. Now, one thing that I'm going to be changing a little bit here is we have a little bit of extra, well, we have extra plate material, but there is another mounting position right over here. I got it marked right here. It's approximately somewhere over here, and I think we can just get on with that one right here as long as we mount this all the way to the edge here. I think we have just enough to hit that other hole and have enough clearance around it for a secure mounting position. And then also our axle is intruding right here. You can see right here the grease is hitting right here, so we want to probably cut that out a little bit. Here's what our plate looks like once we've transferred our lines over and our little dots for our center line of each hole. So the next step is to take your center punch and punch out those center lines, and that's just to make sure that when we start to drill, that our drill bit doesn't wander off course, because it will tend to do that. So we want to make sure, try to keep it as precise as possible. Here's what it's looking like after drilling some 3/16 pilot holes. That's just kind of a starting point. Next thing we'll do is we'll step it up to a bigger drill size and go ahead and enlarge those holes, make them bigger. Okay, with those holes cut out, now we're ready to go ahead and cut out some of these openings here. I'm going to start in here in the middle, because we have these holes set up right here. These we're going to customize a little bit later, so I didn't even drill these out all the way yet, because I want to fit this thing first and then reset it in there just to make doubly sure that we're right on point here. Want to be as accurate as possible. Don't want too much slack in it or anything. It's a nasty tool, but does the job. So here's what it looks like fully installed. This is our final test fitting here. So I've done a whole bunch of numerous test fittings before this. I'm just going to spare you the whole process there, but basically I can summarize it. It's basically, this is the 9th time where we've installed it here, as we had to custom change some of the holes. The holes were accurate, but they weren't super precise. I wanted this to be as precise as possible. I want to have like next to no slack whatsoever. So each individual mounting hole was cut precisely and then enlarged slowly, one bolt at a time, basically. Just, you know, if I needed to adjust it, I would adjust it separately. So basically, I started with the two on top were basically lined up perfectly, and then the bottom two motor bolts were lined up perfectly, but the other two had to be adjusted on the motor. The two upper ones had to be adjusted. And then I started to go around and did this one, was the 3rd one I did as far as the plate mounting to the transmission, and then the 4th one was the one down here. that one right there, and then the 5th one was the last one I did, which I don't even have a bolt in it right now because it's so hard to get to. And that would be this one back here. You can see that or not? Okay, there it is. So that's the 5th one. But it's all lined up. Everything's looking good now. So I think we're at that magical point here where we have it working. Everything's looking like it's going to work here. So now all we have to do is remove it and then sand off. There's a whole bunch of like rough edges on this. The plasma cutter leaves it's a pretty rough cutting device. So we're going to sand it down a bit, kind of grind wheel, soften up some of these rough edges, and then we'll sand it down and paint it, and then it will be ready for final installation. And here's our adapter plate removed from the vehicle. So this is what we have right here. So I'd like to go over a little bit of my experience here. Using the plasma cutter is like using a chainsaw. It's good for fast, rough cuts, but it leaves a lot of nasty melted metal that you have to tap off, and then you have to use an angle grinder to pretty much smooth it out anyway. So I'm not sure if it's the best method to cut with. You just have to be aware that you are going to have to come back with an angle grinder and then finish it off. So that's what I'm going to do here. I've already kind of done some of it as I was cutting my holes out and fine-tuning everything, because I got this thing pretty precise now. So it took a lot of fine-tuning here. Like I said before, probably about 8 or 9 test fittings on the vehicle. Just basically getting a couple holes lined up, and then basically fine-tuning these other holes, and then working my way around the perimeter. Doing this one last. You can see this one needed to be adjusted more. Got it adjusted down there. And here's what our plate looks like after being painted. Unfortunately, it's winter time, so not the best painting weather here in the Pacific Northwest. 45 degrees is about as warm as it was outside, so I wasn't able to get a good paint quality on this one here. But I think we have enough protection on it. It should be adequate. This side's not very good at all. But anyway, we'll have to make do with that. And then, so I just wanted to kind of go over. So we started with our original template, and then we have our working prototype here. It's not perfect, there's a few imperfections, but the holes have been adjusted correctly. So I went ahead and made another template here, I guess, for future use here. So this is basically right off of here, so we know exactly what's going on here. And so I'll have this, I'll be able to take this to maybe a CNC shop or something, have them program it in, trace over these lines, program these holes exactly, and then we'll be able to maybe do a little bit of somewhat of a mass production run. Well, not mass production, but it would be a low production run of maybe we could do 10 of these or something, or maybe 20 or something like that. If there's enough interest, I could maybe have them put together something. And so anyway, that's a possibility. I don't know if I'll do that or not, but let me know if you're interested. And maybe go into production and offer these plates for people. So here's what our motor's looking like now that we have it installed. It came out pretty nice here. One thing I did change is I added some shims here, some washers between the motor right here and the plate, because it looked like there was kind of a little bit of conflict there, so I want to make sure that we don't have any touching of the shaft to shaft here. So it seemed like I needed just a little bit more room there, so I just added those shims in there, about 1.5 millimeters or so thickness. And so yeah, I think it's looking pretty good. It's nice. It's fully tightened down right now. It's on those 5 bolts. All of them are using lock washers. Let's see if I can show you here what it looks like inside. There we go. So you can see right there through our little porthole here, you can see how it's fully resting on the shaft there, on the splines. So we have full contact. And yeah, we've got clearance. We've got pretty good clearance here. I can reach in here and grab these. I'll be able to get to these real easy, no problem. Lots of room on the side here. Now, one thing I've been kind of debating here is, I know that the motor is significantly lighter than the engine, and so what the original plan was is to use just these three mounts. We have our original left mount, and we have the front mount, and we have the rear mount. Of course, the original engine had an additional fourth mount on the right side of the car, which is right up there. But I thought that once I did the motor, I think because it's lighter, I figured that the three mounts are probably going to be perfectly sufficient, and it's probably true that they probably will be significantly efficient. But the thing is that I'm all about longevity here, so I really would feel better if, now that I've got it installed and everything, I feel like there's still a lot of weight cantilevering off here, and I kind of would like to just go ahead, especially since we have a mount there and it's not that far away. I think we're going to go ahead and install the mount anyway. Just for that longevity factor, I like things to last. So I've got the original mount right here. As you can see here, it just kind of goes in right about there. So I did allocate enough room in anticipation of this possibility of this happening. I did make sure that the batteries were out of the way. So it's going to be tight, but I think we can make it work here. So looks like we can looks like that's our alignment right there with where the mount's going to be. Here's what our new engine mount brace to motor is looking like here. And so what I did is I recycled a piece of bracing right here. This was formerly used right over here for the transmission to the engine. It was one of the braces. There's like several of them. There's like 2 or 3 of them that were bracing the transmission to the engine. So I was able to just find a piece that just so happened to work out pretty good for our application here. So it's a nice, strong, sturdy piece. I did have to bore out the hole here, enlarge it so that this bolt can go into our motor. And then I had to cut off the end here, and then I had to drill a new hole that lines up with our bolt that's going through up here. So what we have happening here, this is what this is looking like. So we're just using one hole there. And what I'm doing is I found some bolts like this one right here. I have 2 of them. So this came off the 500E. So I basically was able to salvage that and reuse it for a good purpose here. So I'm using one of them right here, and that's what's bolting it all together. And you simply just tighten that thing up down below to increase the load on it. So basically right now I have very little load on it. I'm just trying to use it. It's just a fourth mounting position for our whole assembly here. So we have our motor and we have our transmission. So we have the other 3 are the primary ones here. This is the front one, and we got the left one, and we got the back one. So now what we've done is we've just kind of lightened the load on those other 3 a little bit and have a little bit of the load going on there. And so if I want to increase the load, I could just tighten this nut right here, and that would pull up on it, and it would basically put more pressure on that one mount compared to the other 3. So we can kind of adjust it. I just want to have a little bit of load on it just to kind of keep it all make it a little bit less stressful for the other 3 mounts. So basically we got 4 solid mounts now.